Hello and welcome to the Chemistry Academy. In this video we're going to go over the National 5 Chemistry 2018 section 1. We will go over section 2 in other videos just so this video doesn't end up too long. So if you're looking for help with any of the multiple choice questions within the 2018 National 5 Chemistry paper, then you can just skip along to the questions that you're looking for help with. So if we get started, the first question is asking which of the following changes would not speed up a chemical reaction. So remember, when we're looking to speed up a reaction, we can increase the concentration, we can increase the temperature, we can decrease the particle size, or we could add a catalyst. So the one that doesn't match those things is increasing the particle size, because that actually decreases the surface area, so the reaction actually ends up being slower because there's less areas available for the particles to collide with each other. Okay, so just remember that with particle size, a larger particle size actually gives a slower reaction. A smaller particle size gives a faster reaction because it gives a larger surface area. Question 2, which line in the table identifies the correct location of a proton and an electron in an atom? So the proton is in the nucleus, the electrons are outside of the nucleus. So that gives us the answer B. Remember, the neutrons are inside of the nucleus as well, and overall the nucleus will have a positive charge because it's got positive protons and neutral neutrons in it. Question 3, which of the following elements does not exist as diatomic molecules? So you just need to know which elements are diatomic elements. If we go to the periodic table, you can remember them as, if you start from number 7, draw a number 7, down to iodine, and that gives you 6 of them. And then the other diatomic element, the 7th one, is just hydrogen, so you just need to remember that one. The other way you can remember the diatomic elements is with the word, it's not really a word, Hinkelbroth. This is my favourite personal one, and that gives you the symbols for all of the 7 diatomic elements. We also have mnemonics like, oh, never fear, have ice cold beer, that will help you remember the symbols. The cold in the beer at the end, I'm not a fan of because it should really be cloled to remind you that it's chlorine and not carbon, and breer to remind you that it's bromine and not boron. So anyway, whichever of those 3 ways works for you. So then if we look at that list of elements we're given there, then it's helium that is not a diatomic element. It is in fact a noble gas, so it would be monoatomic. When the elements are diatomic, just means that they'll exist as O2 or like Br2 or H2 if they are not within a compound. If they're in a compound, you can have a single one of those atoms within the compound, but if they're just on their own in elemental form, they have to be diatomic. Then question 4, we're looking for the shape of a molecule of hydrogen bromide. So to work out the shape of the molecule, we need to know its chemical formula. So we need to do a little bit of the swap and drop, or SVSDF. So the symbols for hydrogen bromide would be hydrogen bromine, so H and Br. If we look up the valencies, hydrogen is in group 1, which means its valency will be 1. Bromine is in group 7, which means its valency will also be 1. Just remember the valency pattern goes 1, 2, 3, 4, 3, 2, 1, 0. So that's the bonds that each of those groups of elements can make. So then we've got the valencies 1 to 1, we swap them, gives us 1 and 1. We can't simplify that ratio, so the formula ends up as HBr. That means that we would end up with 1 hydrogen atom, 1 bromine atom, so it's going to end up giving us that linear shape. Okay, so to work out the shape of a molecule, you need to know its molecular formula. Then question 5, which of the following elements forms an ion with a single positive charge and an electron arrangement of 2, 8? So if we start off with the single positive charge bit, it's the elements in group 1 that end up with single positive charges. If we go to the electron arrangement page here, everything in group 1 will make a single positive charge, everything in group 2 ends up as 2+, group 3 end up as 3+. Group 4 don't tend to form ions, so I'm just going to skip them. And then when we get to group 5, that's when they start gaining electrons and become negative ions. So group 5 become 3 negative, group 6 become 2 negative, group 7 become just a single negative, and again group 0 don't form ions because they already have stable electron arrangements. So we're looking for an element that is in group 1. So that would be sodium, is the only one there actually. Because magnesium, it would form a positive charge ion, but it would be a 2 positive because it's in group 2. So because sodium's got the electron arrangement 281 as an atom, it will lose that 1 electron to get a stable electron arrangement like neon, which is 28. So by losing that 1 electron, it's going to end up as a single positive. So that's our answer there. Okay, like I said, magnesium would end up being 2 positive because it has to lose 2 electrons to become a stable ion. Fluorine is in group 7, so it would gain 1 electron to get stable electron arrangement and become a 1 negative charge ion. So it would be F minus, and neon doesn't form any ions, so that's not possible. So then question 6, this is a common type of question, the multiple choice for bonding and properties of bonding, so get to know how to do them. The properties of a covalent network. So for the covalent substances, you're looking for the no conductivity first of all, so that rules out C and B because they don't have the no conductivity. Remember, covalent substances do not conduct at all. The one with the yes would be metallic, a metallic lattice. That's the one with the yes conductivity. The no as a solid, yes as a liquid, is always an ionic lattice. Okay. So then to decide between the 2 covalent substances, one will be a covalent network, the other will be a covalent molecule. The covalent molecule is the one with the really low melting and boiling points. So that means A would be the covalent molecule. Oh, sorry, silly thing. And D then would be the covalent network because it's got the very high melting and boiling points. So covalent networks tend to have melting points above 1000 degrees. Okay, the reason I've gone through all of these to tell you which one's which is so that you know for when this question comes up in your other exam, like if it comes up in your exam, you know how to identify the one you're being asked for, because you won't necessarily always be asked for the covalent network. Okay, so that's the process to go through. Look at the conductivity information first, and then if you're trying to decide between a covalent network or a covalent molecule, look at the melting and boiling point after you've looked at the conductivity information. So question 7, we've got some numbers, so that gives us a clue that we're probably going to need a calculator. So we've got 1 mole of sodium hydroxide dissolved in water, and the solution was made up to 250 centimetres cubed, and you're asked what the concentration was. Now, calculations can be quite hard to know where to start, so what I often do is write the numbers out of the questions next to the letters that those variables are associated with. So for example, 0.1 mole is a number of moles, so I would write N equals, and 0.1. Then we've got a volume, so that'd be V equals 250 centimetres cubed. And then we're looking for a concentration. Now putting in the question mark is probably the most helpful thing because it helps you see where you need to get to. So we've got a number of moles in a volume, we need to find a concentration, so that shows us we're going to need to use the NCV relationship. This equation is actually at the front of your data booklet on the contents page, so you don't need to remember it, but some of you maybe use the triangles where you've got N and then C and V on the bottom. One thing you need to remember about your volume is it always needs to be in litres here, so we need to divide that volume by 1000. So that would actually give us a volume of 0.25 litres. Now all we have to do is plug it into the equation. So the concentration would be in the number of moles over the volume. So we have C equals N over V. So we'd have 0.1 divided by 0.25. And then if you put that in your calculator, I'm going to guess it gives you 2.5. But no, I guessed wrong. It gives you 0.4. So when you put that in your calculator, you get 0.4, and that gives you your answer. The units will be moles per litre, but it's not really important here, and they usually give you the units in the question anyway. So then for question 8, this is another common question that comes up in the multiple choice. You need to just know these statements. The statement that's correct for an alkaline solution is where it contains more hydroxide ions than hydrogen ions, so that would be B. A can never be true. You can never only have one type of ion. You will always have a mixture of both the hydrogen and hydroxide ions, so that's never true. More hydrogen ions than hydroxide ions, that's for an acid solution or an acidic solution. And the statement at the bottom, the equal concentrations, is for neutral water. Okay, so try and remember those statements as well. They're also very good to put into open-ended questions that are anything just so related to pH. It's always good to get some extra chemistry in through those. So then question 9, a student made some statements about the effect of adding water to an acidic solution. Identify the correct statement. So I quite often like to draw a wee pH scale for these questions, or put pH 1 and 14 and then 7 in the middle. And then I also like to put in the ions that are more common or in higher concentration at those pHs, because as you'll notice, you get statements about the ion concentrations. So acids would have more H+, alkalis have more OH-, and in the middle it would be equal. So if we then look, we've got an acidic solution, so that means we're starting with a lower pH. As we dilute it, it's going to be, because we're adding water, we're diluting it, it's going to move towards 7. So as it moves towards 7, the pH is actually going to increase. So that means that A and B can't be true, because they don't state that the pH is increasing. So then it must be to do with the hydrogen ion concentration. Because we're going from a pH with more hydrogen ions to where it's more equal, then it means the hydrogen ion concentration is going to have to decrease for them to balance out. So that means C is our answer here. Okay, if we were diluting an alkali, the hydrogen ion concentration would increase because we have not so many hydrogen ions at this end, we've got more hydroxide ions. So as they start to equal out, then it means you must be getting more hydrogen ions as well. Okay, so this scale thing does really help with these questions. It stops your brain from getting a bit confused with the whole thing. Then question 10, the shortened structural formula for a compound is shown. Which of the following is another way of representing this structure? So what we need to know here is that anything in brackets is technically a branch. And you can sketch this out fully if you want to. So if we change it into a full structural formula, we've got a C with 3 H's, and then a C with 2 H's, and then a C with 1 H and a branch, and then another C with an H and another branch, and then we've got a C with 2 H's, and then another C with 2 H's, and then a C with 3 H's. So then you just look down at your answers and see which one of those you've got. It doesn't matter which way the methyl groups or the branches are pointing. Either it can be up or down. It's the same thing. So then we should find that the one that matches is D. Okay, so just remember anything in a bracket is technically a branch. If we then go on to question 11, the molecule that's an isomer of that molecule shown there. So the molecule we've been shown is an alkane. It's got all single carbon to carbon bonds. That means its isomer will have to be another alkane. So alkanes can only be isomers with other alkanes. That means that A is not going to be an isomer. It's not going to have enough hydrogens because it's a cyclic. It's a cycloalkane, so they have the general formula CnH2n, whereas alkanes have the general formula CnH2n plus 2. So they're never going to have the same number of hydrogens if they have the same number of carbons, which means they're never going to have the same molecular formula with having a different structure. So we're looking for something that has if we count the carbons here, 1, 2, 3, 4, 5, 6 carbons. So if we look here, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. So it can't be D, it's not got enough. So now we're deciding between B and C. In isomers questions, once you get down to the last 2 possible answers, usually one of them is actually the molecule that you've been presented with in the first place, so just look for anything that looks like it's a mirror image. If you're not too good with seeing mirror images, name them and make sure the names are different. So if we were to name this molecule, it would be 2-methyl pentane because there's a methyl group on carbon 2. So I'll just write that down, 2-methyl pentane. If we were to name B, we would have to number from the right hand side because that's where the branch is closest to. So again, that would be 2-methylpentane. So that's actually the same molecule. So that's not an isomer, that is the same molecule, which means our answer must be C. C is 3-methylpentane, which confirms that it is an isomer because it's got the same number of carbons and hydrogens, but it's got a different name, which means it will have to have a different structure. Okay. One thing to bear in mind with the isomers questions as well is that, remember, alkenes and cycloalkanes can be isomers with each other if they've got the same number of carbons, because both of those homologous series have the same general formula, CnH2n. Okay, so that's just something that helps to narrow down options. So then question 12, which of the following reactions takes place when an alcohol is formed from an alkene? So if we're starting with an alkene, we'll just draw ethene here. And we end up with an alcohol, so we draw ethanol. Then what we'll have to have done here is added water to it, because what we've done is we've broken the double bond and added an H to one side and an OH to the other. See that? So that means it's hydration. So the addition of water is called hydration. If hydration wasn't there, you would just refer to it as addition, but we've had to add a molecule of water. Hydrogenation is where you've added just hydrogen, so that's how you would convert an alkene into an alkane. Then question 13, the systematic name of this carbon. One thing you need to watch out for that they love to do in the exams is put the longest chain of carbons in an L shape. So make sure you always check in L's for the longest chain of carbons. So we've got 1, 2, 3, 4, 5. So that is in a carbon chain. It's a long carbon chain, it's not a branch. This one at the end here. Okay, so because we've got 5 carbons, that means it will be pent. And it's got a hydroxyl group, which makes it an alcohol. And we number from the end closest to where the hydroxyl group is, so it would actually be pentan 2-ol. So that gives us A. Okay, so just watch out for the L shapes, I'm telling you now. Which of the following alcohols is least soluble in water? So molecules get less soluble the bigger they are. So the bigger the molecules get, the less soluble they become. So in terms of which one is the biggest molecule here, we've got hex, and 1-ol would be the biggest because it's got the most carbons. Okay, so bigger molecules are less soluble in water. That's something worth remembering. Melting and boiling points also increase as the molecules get bigger as well, and that's because the strength of the intermolecular forces will increase as the molecule increases in size. So then question 15, energy from fuels experiment. The apparatus setup that will produce the most accurate result is where you have your copper or metal can, because that's a better conductor of heat, so more heat will be conducted into the water, and where you have the draft shield so that it minimises heat being lost to the surroundings. So that would be B. Okay, the glass beaker is not great because it's an insulator, so it stops heat from being transferred into the water. And yeah, if we don't have the draft shield, it means that heat can be lost to the surroundings and it's not transferring into the water. So that's what we're wanting in this experiment, is for as much of the heat that's been released from the fuel that's been burned underneath to reach that water, so we can record that temperature change. So then 16 is a bit of a problem-solving question, and you're shown a reaction, and then you're asked to work out which pairs of molecules would then give you the compound that they've shown there, 2-ethoxypropane. So what you want to do is kind of play a bit of a game of spot the difference with yourself. So if you look at the example you've been given, how has this changed? Well, we can see the H from the OH has come off, as well as the chlorine from this molecule here. So what we want to do then is apply that to this. So if we were to split this up, we would have something that had an OH and something that had a Cl to start with. So that means it can't be A because that's 2 OHs, and it can't be D because that's 2 Cl groups on the molecule, so they don't fit the example that we've been shown. Okay. Then we're deciding between B and C. So if you look at where they join where the functional groups are. That means that in B they would join in a straight line because this OH would join where that Cl was. But we need it to be in that sort of like T shape, so that means that the Cl is going to have to be in the middle, so that ends up forming that sort of T shape. So the answer would be C. Okay, so these ones can be a little bit tricky, but just try and play a game of spot the difference. See if you can, in really simple terms, notice what's changed in the molecules when they've reacted, and then reapply that change to the example that you've been given. Question 17, placing the metals in order of reactivity, starting with the most reactive. Now this is the key bits that people tend to get wrong here, is they forget which order they're going in. So if you're starting with the most reactive, I would put a wee note to yourself, you're going from most to least. So then the most reactive is the one that will react with most stuff quickly or slowly, so that would be X being the most reactive because it reacts fast and then slow with water, whereas nothing else reacts with the water. Then the next one that reacts fast with acid is Z, so that would be our next one. Then W is a moderate reaction, so that would be next. And then Y is the slowest reaction with acid, so that would be last. So then that should give us our answer A. Okay, so the biggest tip with this one is just make sure you know what order you're writing the reactivity in, if it's starting from least going to most, or starting with the most going to least. And make sure you write down the direction you're going in so you don't get confused. Then writing the overall redox equations, what you need to do with these, remember, is get the electrons to balance so you can cancel them out. So that means we need to times this top one by 2. So if we multiply that through by 2, you end up with 2 moles of hydrogen, 4 moles of hydrogen ions, and then 4 moles of electrons. Those electrons can then cancel, and then everything else kind of just gets squished into the same line. So you should have 2H2, which means you can't be A or C. Then 2H2O. Also, if you struggle to see which side stuff's on, I would encourage building like a wall between the two sides of the reaction, just so you don't get stuff on the wrong side. So 2H2O, which means B is a potential, and it looks like it's the right answer because in D they've still got the electrons in, but we don't ever want to keep the electrons in there. Okay, for the overall redox equation, should never have electrons in it. So then question 19, which of the following metals when connected to lead in a cell would produce the highest reading on the voltmeter? So remember, the higher voltage will result from the metals that are furthest apart in the electrochemical series. So if it's getting paired with lead, we're looking for which one of these metals is furthest from lead to give us the highest voltage. So if we go to the electrochemical series, lead is here. The one that's highest up, I think, is zinc. Yeah, zinc's the furthest away, it's up here, because we've got nickel and tin, and then if lead was paired with lead, it would give you a value of 0 volts. So if it's the same metal, it just ends up as 0 voltage. And then which one of the following salts could not be used as a fertilizer? So fertilizers need to have two things. They need to either contain at least one of the essential elements for plant growth, which are nitrogen, phosphorus and potassium, and they need to be water soluble. Okay, so that's the two requirements for a compound that can be used as a fertilizer. If we look at what elements are in these, so ammonium chloride would have nitrogen, hydrogen and chlorine, so that's got one of the essential elements for plant growth. Ammonium phosphate would have nitrogen, hydrogen, phosphorus and oxygen. I'm not doing the chemical formulas here, I'm just putting what elements are in it. So that's got two essential elements for plant growth. Sodium chloride would be sodium and chlorine, so that doesn't have any. And then sodium phosphate is sodium and then phosphorus and oxygen, so it's got the phosphorus. So the one that's not suitable would be sodium chloride because it doesn't have any of the essential elements for plant growth. If all of them had one of the essential elements for plant growth, then you would go and look at the solubilities table and check to see if there were any that were insoluble. So you would look up here and see, but you should find that all of those substances are actually soluble, so the solubility isn't the issue there, it's the element that's in it. So then the metal that's used as a catalyst in the industrial manufacture of ammonia, that is iron. Ammonia is produced in the Haber process, and and the Haber process uses the iron catalyst You can actually use the alphabet to help you remember which catalyst goes with which reaction, because the starting letters are next to each other in the alphabet. The other process we look at when we're looking at industrial processes is Ostwald process. So obviously that starts with an O. Its catalyst is platinum, which starts with a P, and P comes after O in the alphabet. I think that's just a really random coincidence, but it's quite a useful coincidence to remember which one goes with which. Then you've got to identify which types of radiation are being shown by X and Y. So X is going towards the negative plate, which means it must be positively charged because opposites attract. And the positively charged radiation is alpha. So that means not B or C. Y goes directly through the middle and is not affected by either charged plate, which means it itself doesn't have a charge. And the radiation that doesn't have a charge is gamma. So the answer must be D. If you had a particle going towards the positive plate, then that would be a negative particle, and that would be the beta radiation because it's the electron, negative electron. The description of metallic bonding, this is just something you need to memorise. It's always the positive ions surrounded by delocalised electrons. A lot of people go with the negative ions and delocalised electrons. Just remember that the delocalised negative electrons would not be attracted to negative ions because like charges repel each other. So it's always the positive ions with the delocalised negative electrons floating around the structure. Then the type of reaction that is taking place here. So the best thing to do when you're looking for a type of reaction question, first of all, is to scan through the state symbols. You should see that they are basically all aqueous except for one thing, which is a solid, and that's a sure sign of a precipitation reaction. If it wasn't a precipitation reaction, then you would go and look for any identifying features of any of the other types of reactions. If you're not sure of what they are, you can go and have a look at my types of reactions video in my National 5 chemistry playlist. That should help. But always check for precipitation reactions first anyway. They're the easiest ones to spot. And then last question, which order the experiment should be carried out in if you're preparing copper sulfate crystals. So when you're preparing the copper sulfate crystals, you need to add an excess of copper carbonate, as they said here, into an acid. That will fizz until you've added enough copper carbonate. It will fizz because you're producing carbon dioxide gas. So once the acid's completely reacted and completely neutralised, you won't get any more carbon dioxide gas being produced. That's how you know you've added enough of your copper carbonate. But then some of the copper carbonate won't have reacted, so you'll have solid bits floating around. So that means you would then need to filter it before you actually then go and evaporate off the water. So you would start off by adding your copper carbonate, you then filter off any excess solid, and then you evaporate off the water to get your dry sample of your crystals. So it would be Y, Z, and then X, which gives you D. Okay. So I hope you found that useful. Like I said, if you're looking for help with section 2, then you can go and find my other videos in the National 5 Chemistry playlist. But don't forget, I've got all the full tutorial videos to help you with any subtopics that you're maybe struggling with. So if you have identified any subtopics that you're finding a bit more challenging as you've been going through past papers, then go and have a look at them also. So if you find this useful, please give the video a like. Don't forget to subscribe, and I will see you again soon.